This is a large language model. Now, we've all used it, so let me put on an example. So it can generate text and do it quite well, better than most of us, let's say. But what goes on behind it is what we're going to look at today. So I'm going to break down how this works and what goes on in the background, so you understand it. So it's not a mystery anymore, basically. So this is what goes on in the background. No, it looks complex, but it really isn't, because a large language model is basically, it's just a bunch of math. It's a biased coin being flipped. So you put in your inputs, and that's context, and it generates more text based on the context you give it. So you give it some text and it generates more text. So we're going to be looking into how LLMs work and how you could build one of your own if you ever wanted to. Okay, like I said, I'm going to be breaking down how LLMs work, why they're not magic, and basically, once this is over, you're gonna know exactly what goes on in the background when a model generates text for you. So I'm gonna get started right away. So why are large language models so good at generating text and images and video? So basically, imagine this. Somebody forces you to read a book, say 1 billion times or even 100 billion times. Once you've read that book 1 billion times, I think it's going to be pretty easy for you to recite every word in that book, draw inferences from it, make connections with other material from that book. And that's basically what's going on here. So just like your brain makes connections and learns everything about that book you read 1 billion times, which nobody's gonna do, I'm pretty sure. Hey, you could. Yeah, so basically we force a simplified brain, think of it like that. We force a simplified brain during training to read a large corpus, a whole library, or like 100 libraries, read all the text over and over until it can draw connections from it that are meaningful. And this is basically the experience it gets from this corpus is exactly what it's using to perform tasks for you. So this is basically a trained prediction engine. It's not something that understands anything. It's just a prediction engine that has a single purpose, which is to guess the next token. And that's really all that an LLM is doing, is trying to guess the next token correctly. And then when this is done at scale, it starts to be able to do a lot more. And that can really be useful, which we already know at this point. So they're highly sophisticated statistical engines grounded in math, so that's half of it. Math is half of it. And probability is the specific part of math. Of course, there's calculus and backpropagation, but probability is a huge part of it. So we're basically, yeah, I'll cover probability and math later on, hopefully. So rather than understanding or consciousness or intent, I see these things going around a lot in media. It's like, oh, look at this, an LLM is conscious, or like I asked ChatGPT to generate an image of itself, but it's really just it's just calculating the next most probable word or token to itself, because it can't it can't even comprehend words as we use them. They're converted to tokens. So I'll cover this later on as well. So it's basically a complex prediction engine. So if you want to explore what an LLM is in more detail, you can take a look at this documentation, let's say, from Cloudflare. So here an LLM is defined as a type of AI model trained on enormous datasets of text. LLMs learn patterns in language and can generate coherent, contextually appropriate text, answer questions, summarize documents, translate languages. Yeah, that's just what we talked about. So an LLM is basically a large language model. So I'm going to be focusing on language models because that's what I'm particularly fond of, and that's what the topic for this is. So it's a type of artificial intelligence, which is a very broad topic in computer science. So artificial intelligence, I'm not gonna go deep into that for now. So it's just a system that's trained, I should say, to understand, generate, and manipulate human language in a way that closely resembles how we would do it. So most modern LLMs like ChatGPT you just saw are just neural networks. And a neural network is just this. So what is a neural network? That's the very next question that probably comes to you. So a neural network is basically it's inspired by the brain and how it works, but it's highly simplified. So I'd actually like you not to think of it as a human brain, because our brains are a lot more dynamic, and then the neurons we have are much more capable than the neurons in language models. So a neural network is the web of interconnected layers of artificial neurons which we feed context into along with weights or biases. So we feed these into a neural network, and then it generates or predicts what it thinks is the next most probable word or token, and adds that to its context to generate more of them. So this varies, the architecture varies depending on models. There are a few open ones you could have a look at. For example, the Llama series, which is a great example of LLMs. So it receives raw data from the user and makes use of that data in order to make more of it. Yeah, so I'll be jumping right into how LLMs are made, and basically once you understand this, you'll know exactly how they work as well. So the first part of making an LLM is basically data collection. Now this is probably one of the most expensive stages, because if you want to do it on your own, you'd have to scrape a lot of the internet. But the good thing is you don't have to do it all on your own, because plenty of datasets exist. So basically, while collecting data, all you're doing is taking a lot of text from the internet, like a lot of text from various websites on the internet. So internet is a huge place. So there's a lot of text there. So you're just taking a lot of that text because you'll need it to train your neural network. So the fine web is just one data set. Now this is a really good data set that you could build an LLM out of, technically. And most companies will have a version of this, or probably even just use the fine web because it's already there. So that's basically just a lot of text in the dataset that you feed into your language model so it learns. So this is just an example. So basically this is coherent text. I was also really mad because, so yeah, it's just text. And there's a lot of it, a lot of this text from a lot of time and then a lot of sources. Now, one thing I'm not going to go deep into, but I'll just put it out there. When you do gather data, you should be careful about what kind of data you're gathering, because you don't want the LLM to learn things that you wouldn't want it to show to the user when they're using it. When somebody's using an LLM, you don't want it to pop up like passwords or negative language or hate speech, things like that. You don't want your LLM to be trained on that. So you usually exclude those things when you create a dataset. So creating a dataset, that's what's happening. You're just collecting a lot of text from the internet and just gathering it all up into one bundle, which you can use to train your LLM. So now the next step is turning the data, which is text, into something the neural networks can work with. Now what do I mean when I say this? So basically your neural network is not able to just look at the word dog or cat and then just understand that it means a dog or a cat. It just doesn't work like that. A neural network does not understand text, it understands tokens. Now what's a token? A token is just a bunch of numbers. It's just a bunch of numbers usually, but it can actually be anything. It's just a unique representation of something that the LLM has internalized. It could be an emoji, a number, but usually it's a string of numbers. Usually four numbers. That's a good way to view a token. Just four numbers, like 76. Yeah. So tokenization is the process of breaking down the raw text into numbers. Now, I wanna use an example of Tick Tokenizer here. You can visit the website. So another thing is basically in modern LLMs, this is quite recent. This is a recent advancement, but in modern LLMs, they're usually provided a system prompt. Say if it's a coding model, the system prompt would be something like understand the code first before making any changes, or something like don't iterate too much, preserve most of the starting code. So things like that would be the system prompt. Those are sent by the client you're using to access a language model through. Now, depending on that, the system prompt is going to vary, or it's not going to be there at all, or something like that. So system prompts can play a very important role in determining the quality of response you get from an LLM, but I'm not going to dive into that. So let's just see. Generate an essay on trees. Now you'll see I made a spelling mistake over here. That's actually an important thing, because here generate is 2 tokens, and one is still 2 tokens, but say for example I mess up the word a little more, it's going to be 3 tokens. Now these tokens are just strings of numbers, like I said, and this is what happens to text when you give it to an LLM. So generate itself is just 1 token, but when I made a spelling error, it converted into 2 tokens, so it could still understand it. So this is what you give to an LLM, and this is what it understands, this is what it sees. It doesn't see the world in text, it sees the world in numbers, or tokens. So these are tokens for GPT-4o, but depending on the model, the tokens are gonna vary. Now, that didn't work for some reason. Turbo. Yep. So the tokens are going to be different for depending on model. Now this depends heavily on the tokenizer itself, which I'm going to get into right now. So the tokenizer is basically something. It's a system that converts human readable text into tokens so that the LLM can understand and work with it. That's basically all a tokenizer is. It's just like Google Translate but for LLMs. That's it. That's all you need to know about tokenizers. Now we get to the interesting bits. Training. It might sound complex, but it really isn't. So we're gonna do an interactive demo of pre-training. Pre-training is basically the stage where your LM learns most of what it learns. So just make sure I can. So this is basically a pre-training script. Please don't get panicked currently because this looks complex, but it's actually really simple. So this is an exponentially small language model in PyTorch. So pre-training is basically the stage where your model goes from gibberish to coherent text, like it understands grammar, it has general knowledge about how the world, or how the internet, I should say, works, because it spends a lot of time here just looking at patterns that occur in text and basically being able to replicate those patterns so it can almost dream the internet. So it can generate things that look like they might belong in the internet, but they actually don't. So it's generating new text, which is text that is very similar to the text on the internet, depending on context you give it. So I'll just go over pre-training really quick. So this code cell imports your dependencies. We don't need to go into that. I'll just wait for a runtime to be allocated here while I explain something called overfitting. Now overfitting, I hope I'm not getting ahead of myself here, but overfitting is basically when your dataset is too small or too repetitive and your language model just starts to basically memorize it. Now I'll cover this in more detail, but I'll just go over pre-training really quickly. So this is the dataset we're using. It's really tiny, of course, and that's exactly, it's tiny for a reason, because I wanted to demonstrate overfitting as well. So this is what happens when your dataset is too tiny and the model can essentially memorize it. So I'll just initialize the dataset, and then basically this is called character level tokenization. So basically I'm converting characters into tokens. This is what I just explained. So we're converting human language into numbers, as you see here. So this is what the model sees. Okay, so just going to run this. So we tokenize, and this is an exponentially small model. Please bear that in mind. This is not even comparable to larger models like ChatGPT or Claude. It would be like comparing football with an atom. So this is defining the model itself, which I'm not going to dive into. And this is the training setup and loop. Okay, so of course, since I have a GPU here at my disposal, this is going to be really fast. But as you can see, it starts with gibberish. Like, these are not real words, but after enough optimization cycles, after it's seen the same text over and over and over, it starts to learn a few words like the, fox, brown, quick, and things like that. It learns words slowly, and then at one point the text becomes coherent and it starts to look like human generated text or even understanding, but it's not. It's just repeated learning, almost learning, but it's just optimizing predictions so that they become better. So basically what every neural network works with is weights. Now these weights are something that goes along with your input to the model, and the model uses these weights to basically bias its predictions. Now, before pre-training, these biases are equal for every single possibility. But then as you train the model, the biases start to lean in the right directions. So what comes after the model is gonna give a higher probability to the dog than it's gonna give to the the slip, which makes no sense. And that's exactly why the model is gonna give it lower probability. So that's basically pre-training. I'm not going to let this run for longer because there really isn't a point. This is an extremely tiny model and it still takes really long to pre-train. So pre-training is a very expensive stage of building a model. So most people don't pre-train their own model. They get a base model, something like Llama 7B or even Llama 3B, and they basically do something called fine-tuning, which I'm going to go over in just a moment. I'm going to stop this cycle. So, okay, I'm going to be talking about fine-tuning really quickly. So fine-tuning is basically the process of specializing a model at a certain task. So you take a base model that's already been pre-trained, so you don't have to do it over again. And these base models are generalists, I would say. So they're basically they're fine at everything, but they're not exceptionally good at one particular thing. So you're basically just making a model exceptionally good at one particular thing than good at everything. So I'm just going to be running through training a model really quickly. This is going to be a really small model, so I'm going to be using Onslaught, and this is basically fine-tuning a model for mathematical reasoning. So we're basically just installing libraries here, which I'm not going to go over in much detail. And then here we're getting Onslaught, and this. So here I'm basically just configuring everything to get this going. Like as you can see, this process of even fine-tuning something as small as 8B is quite difficult. So here we're just getting the meta. So I'd like to actually give proper credit to AMD AI Academy for this, because I'm currently using one of their resources. This is from one of their courses, so you can check them out if you want to. They have a bunch of courses. This is just one of them. So this is just installing everything, getting everything done, so we can proceed with fine-tuning. So here we'd prepare the dataset afterwards. I'll just let this run. So we'll just wait for this to complete. Okay, so this is the basic, this is actually GRPO fine-tuning. So it's a type of supervised fine-tuning. It's actually reinforcement learning here, but we're not going to dive into that yet. This is still a type of fine-tuning. So basically, I'll just let this run while I explain. So what's basically happening here is you're just giving specific data instead of general data to the model this time. So you don't have to give it as much data as pre-training. You don't have to do that, but you need to give it specific data. So if you want it to be a good math model, you're going to give it mathematical data of the highest quality. It doesn't have to be a huge data set. It just has to be a data set of high quality. And you're basically giving it a query. So this is turning a base model into an assistant in whichever particular field you'd like it to excel at. So you give it very high quality specific data. It doesn't have to be a lot of data, but it needs to be the highest quality. So you give it this data and it starts to perform specific actions much better. So that's basically all that's happening during fine-tuning. You're turning a generalist into a specialist, if that makes any sense. So during fine-tuning, which I'm currently doing here, you just give it specific things. Like here we're fine-tuning a generalist model for math. So we give it a math question, and then we ask it to generate a response to that math question. Now it's going to be good at generating responses already because it's already been pre-trained, but it's not going to be that good at math. So we ask it to generate its response, and then once it generates a response, now here it's reinforcement learning, so it's going to have a slightly different process, but we're not going to dive into that. So we get the answer and we compare the answer to what we have in our data set. So we compare the answer to the correct answer, and then depending on how well the model answered the question, we either increase the probability of a certain outcome or decrease it. So we're basically slightly modifying the weights of the model, like the parameters. So we're slightly twiddling with its biases so it gets better at specific tasks. And that's basically all fine-tuning is. Now post-training is basically done when you want to change certain behaviors the model has, or give it certain responses to specific questions like what are you or who are you. If you want the model to say it's Rise GPT, it's like you create a tiny data set of questions and answers, and these could be any questions you want the model to learn the answers to, so it doesn't generate the most probable one, but generates a very specific one that you'd like it to generate. Of course, this can be done in other ways as well, which have nothing to do with training, but I'm not going to dive into those. Post-training is basically when you want to make your model behave differently from how it behaves, even if it's after it's fully trained. Now, big companies like Claude, ChatGPT, DeepSeek, they do this all the time. They post-train their models all the time in order to advance them more, push them further, so they can get more users, of course. Now, reinforcement learning, I'm going to do this really quickly. It's basically a type of machine learning where the autonomous agent learns to make the best decisions by interacting with its environment through trial and error. So reinforcement is basically, it's a concept from psychology where you reward behavior that you want to reproduce. So basically when the model does something right, we reward it so it does the actions more frequently. Like here, this is reinforcement learning in action. So here basically, whenever the mathematical model reasons correctly, we give it a tiny reward so it does that more. And as these rewards are given, the model starts to prioritize making those decisions that earn it that reward. So, for example, when a model arrives at the correct answer after the correct reasoning, we give it a high reward. So the model prioritizes doing that more often. On the contrary, if a model does not do what we want it to do, we don't give it that reward, so it stops prioritizing it that much. Now, I'm being very hand-wavy throughout this whole explanation, but I just want this to be accessible to a general audience. So, this is a very high-level overview. Of course, it's much more complex than this in practice, but that's what we're going over. Now, comes the last part, inference. Inference is basically just using the model, and we're not training it anymore here. We're just using the model. So you can do this any way you would like. You could use Claude, DeepSeek. You could use any of these models. And inference is basically generating text from the model. So if I just type in hello, what I'm talking to here is a corpus of data, which is sometimes imbibed with tool use like search features, reasoning, etc. So that's basically what an LLM is, how it works, and that's the whole thing. Now, these are some useful links that you should take a look at. Hugging Face was a neural network, AMD AI Academy if you'd like. So yeah, that's basically all.